property. So the zero product property tells us if x times y is equal to 0, then either x or y has to be 0 or both of them have to be 0. So what that's basically saying, if you're multiplying two things together and it's equal to 0, one or both of those pieces have to be 0. So that being said, you see how these two pieces are both multiplied together? You see how it's equal to 0? That means that this piece, x plus 1, has to be 0, or this piece, x minus 2, has to be 0. So you have to figure out what makes those 0. Well, if you substitute in a negative 1 here, you get 0 times negative 3 equals 0. If you substitute a 2 in for x, 2 minus 0 is 0. So 3 times 0 is 0. So how do we find these pieces? Well, you just solve for x in each of those little pieces. You make mini equations. So you make your mini equations. This only works if it's set equal to 0. There's no such thing as a 2 product property or a 5 product property. It is called the 0 product property, which means it has to be set equal to 0. So this only works if your equation is set equal to 0. Okay, Alyssa. Or not Alyssa, Kaylee. Sorry, I thought Alyssa's hand was up.
Where'd you get 3?
So I'm going to talk about that in a second. So you'll notice when x is negative 1, if I substitute in negative 1 here, I have negative 1 plus 1. Negative 1 minus 2 equals 0. So that's 0 times negative 3, which is 0. I'm going to do this because other people were confused anyways, because some people are more visual.
I just thought you did it from that equation.
So then we have 2 plus 1 and 2 minus 2 equals 0. Well, 3 times 0 is 0. So do you notice that if you solve these, it tells you what exactly will make that equation 0? Again, this only works if you are set equal to 0. So when solving the equation with two of the same variable, you need to set up mini equations and solve them. Sometimes you'll need to break the equation up into pieces before you solve it. So this is what this is saying. You guys, when it's linear, meaning it has only one variable in it, right, like x to the some power. So like if you guys need y equals 2x plus 1, and we wanted to know where this crossed the x-axis, we would set y equal to 0 and solve this. And you would get x equals negative 1/2, right? You can just solve that straight up. You guys are used to that, right?
Yeah.
But when you're talking about this kind of an equation, do you guys see how we have a squared term and a term to the first power, a quadratic?
Yeah.
That's when you have to factor to solve. So a quadratic means you're going to have to factor to solve. In this case, we could technically use completing the square because our a value is 1. Or we could factor this. So we would let y equal 0, and we would factor this. So we'd have x and x in front. 1 times 2 is 2. We need our middle term to be negative, so negative 2 plus 1 is negative x, which gets us here. So when you get here, you then make your mini equations and solve them. Because the zero product property tells us one of those have to be 0 in order to be equal to 0. So there's a difference between what we've done in the past. You guys are only used to solving linear type equations right now, where you just do the normal stuff, right?
Yeah.
So now you are dealing with x squareds or quadratics, which create a parabola, which means you're going to have to do one of the methods you've learned. We've learned by the square root property when it's in vertex form. We learned when a is 1, we can complete the square and then use the square root property. And today we're adding on to it when it's in standard form, and we're going to use some factoring. And that's going to continue into tomorrow. That's why I'm saying don't lose this packet. So go ahead and flip to the next page. Yeah.
For the, is it supposed to be equal 0 for the 3 times 0? Is it supposed to be equal 0? Or is it?
Yes, I lost a line. Sometimes my stylus doesn't. You know what I mean?
Yeah.
Yep, you're fine.
Oh my god.
Sorry, I saw that.
Hey. No.
So as I have said, we are finishing this packet tomorrow. We're not doing this whole entire packet today, so you cannot lose your packet.
Aww.
All right.
That's what I was claiming.
As a reminder, the solving process for factoring. Your first step is to always look for a greatest common factor. If there is, your second part is if it's two terms, you factor using difference of two squares. Remember, it's a minus b times a plus b. The same thing with a different sign in between.
Yeah.
That accidentally rhymed.
And then, if you have a trinomial, three terms, you have to use guess and check. So remember, that's when you list out all the factors of the front, and you list out all the factors of the back, and you try to get it so that it will factor some way here, right?
Wait, what's that thing next to the C?
A 1. And then, if it's four terms, we factor by grouping. You group the first two together, and you group the last two together. You take a GCF out of each piece. And you'll notice when you take the GCF out that our binomials are the same, right? So we take that a plus b out, and we're left with x plus y. So this is what you guys learned in the unit prior to this, right?
Yeah.
All this factoring stuff. Some of you guys have been coming in and doing that retake. So if you are still needing to do that retake, we are going to be talking about factoring again. So this might be a good time to do that.
Do I need to retake it?
At the final point, you should know that. I shouldn't have to answer that. I don't know. So a minus b, a plus b, if any of your binomials are difference of squares, make sure you continue to factor. So that is just a quick rundown of what you guys learned last unit. So now, how are we going to do this if we're solving by factoring? If you see an equation with 2 being the highest degree, the highest exponent, you no longer have a linear, so you have to try to solve by factoring. It is not like the linear I gave you guys where we got like x equals negative 1/2. It was just a random thing I put up there. If you see something with the highest exponent being 2, you have to solve by factoring, or it's one of the other methods that we have learned, but today it's going to be factoring. You're going to get the equation set equal to 0 in order to use the zero product property. This is super important. The property is called the zero product property, which means it must be set equal to 0. That is the only product property we have. Once you have that done, you are going to look for a greatest common factor first, and then you'll either factor if it's 2 terms, 3 terms, or 4 terms. So whichever method it is, you'll go there. So what do your solutions mean? They are where they will cross the graph and the x-axis. When you're on the x-axis, remember your y-coordinate is 0. So that's why we're getting it set equal to 0, because we're trying to figure out when y is 0, what is our x. So remember, if it's 2 solutions, then it crosses the x-axis twice. If it's 1 solution, the vertex is lying on the x-axis. And if there's no solutions, but we say no real solution, right? Or no real, what else do I say? Or no real zeros. It doesn't matter which way you say. That means that you're never crossing the x-axis. And you will find that those are imaginary solutions when you get to Algebra 2. All right. So let's try to do some of these problems. Go ahead and flip to the next page.
Coordinates.
I need a minute to reflect myself.
I just want to go to bed.
No, Lexi. Oh my God. Stop. What's on my mouth? Shut up. Hey.
Okay, so notice this first one's already factored for you. And we said once it gets to the factored form, we can make mini equations. So the mini equations are going to both be set equal to 0. So we have x minus 2 equals 0 and x plus 1 equals 0. Just as a side note, you guys know how you guys have learned vertex form and standard form of graphing? This is called intercept form. You might see this sometimes, where it just gives you the x-intercepts, and you can plot the x-intercepts to figure it out, and you kind of talked about that a little bit today in lab with, I think, Stein, where he showed you the vertex, like the line of symmetry and stuff in the middle of it. Teacher next door. So, we solve for x. So x equals 2. And we solve for x here, and x equals -1. So what does this mean? Let's think about this. That we have a point at -1, and we have a point at +2. So the vertex has to be halfway between those two, right?
Oh yeah.
So where would my vertex be? What's halfway between those 2 points?
Yes.
What 2 points?
Right, because 1 and 1, right? So they have to be halfway between. So your vertex is somewhere 1/2. Now this one's going to be too confusing to figure out because it's 1.5 out, and we've never really talked about 1.5 out. But we know that our vertex needs to lie. We know that the vertex needs to lie in between. Can somebody explain to the class why the vertex needs to lie somewhere between there? Yeah.
Because, you like, it's like symmetric, so like if you like do half of like what's implied, there's like 3, so half of 3 would be like 1.5.
So you go 1.5 over from each point. Guys, remember, parabolas are symmetrical, which means that, guys, don't just say random words. Don't just say random numbers. Stop it. Parabolas are symmetrical, which means anytime there's 2 points in the same horizontal, it needs to be halfway between. Do you guys understand that?
Yes.
So we know this is 1/2 comma something. It is going to open upwards, right? So it's probably going to have a point somewhere down here, and it will look something like this. Now that's not the exact graph, but we know it's something like that. That's what this is saying. So let's try the next one. So the next one isn't factored yet. First thing you always have to check for is it set equal to 0? So is this set equal to 0? Yes. So once it's set equal to 0, since we have a 2 as our highest exponent, we are going to look to factor. You look for a GCF first. Jordan, what is my GCF? You can take an x out. So we take an x out of both, and we are left with 5x minus 1 equals 0. So you'll notice here, this is a binomial. Is that a difference of squares? It's a difference, but is that a perfect square?
No.
No. So you are at the point where you can create your mini equations. Each piece needs to somehow equal 0 at some point for that to be equal to 0. So do you see my 2 mini equations? I have an x and a 5x minus 1. You'll notice that any multiplication creates a mini equation. So we have a mini equation of x equals 0 and 5x minus 1 also equals 0. So x is 0. How can I solve that other equation there? What am I going to do? Yes.
Add 1 to 0.
And then what are you going to do?
Divide, in which case you would just get 0.
Nope.
Or negative
You divide by 5, so you get x equals
5.
1 over.
Oh, 1 over.
So you guys got to remember, if this was originally, we just said graph it, you guys would have had to do the negative b over 2a, find the vertex that way, and then plot it. And you would not be able to tell me in an exact point if it's 1/5, would you?
Nope.
No, now you're able to find those points. So we have an answer at 0 and 1/5. Justin. You have to factor first so that you can create your mini equation. Yeah. All right. RC. The first step in number 3 or in any time that your highest exponent is 2 is to look to make sure it's set equal to 0. So is it set equal to 0?
Yeah.
Yeah, because remember, we're using the 0 product property, or we're trying to find when y is 0 when it's crossing the x-axis. So that's the 2 reasons why we're really looking at this. So RC, there, it is already there. So what is my GCF?
2.
Bigger. What goes into both 12 and 4?
4.
And what else can you take out besides 4? not a number. Look at your variables.
Oh,
You can take a 4x out. So we take a 4x out, and we're left with 3x minus 1 equals 0. So Blaine, what are my mini equations for this one?
4x equals 0.
Good.
And then 3x minus 1 equals 0.
Perfect. So once you get to the factored form, you can create those mini equations. So we solve. Grace, 4x equals 0 means x is?
0.
Divided by 4, and we get 0. Good. J-Law, what would I have to do to solve the other one? Add 1, divide by 3. So again, you'll notice we're getting a fraction here. If you were to have graphed this using x equals negative b over 2a, substituting that back in to do the vertex, and then using your pattern, you would have had to tell me between 0 and 1. But now that we have it this way, we can say it as an exact answer. Remember, you can write it up in set notation as well. You don't have to do both. So what have I been saying over and over again that is different about number 4?
It's 0.
It doesn't have a thingy.
Perfect. So a couple of you guys said it here. It does not equal 0. Remember, we're using the 0 product property, which means it needs to be equal to 0. We're trying to find when it's crossing the x-axis, means y is 0. That's why we're getting it set equal to 0. So what is the first thing I need to do to get this set equal to 0? Go ahead, Lexi.
Subtract 49x.
It's adding. It's positive. Are those like terms? Are these two like terms? No. So I have 7x squared minus 49x equals 0. So now it's set equal to 0. The first thing we look for is a GCF. What is my GCF, Connor? What? 7x. So I have 7x equals x, or 7x times x minus 7. Is x minus 7 a difference of squares? No, those aren't perfect squares, so we are good there. Yeah.
So I get why we subtract 49x.
Because it has to be equal to 0 to use the 0 product property. That's what the 0 product property says, that it has to be set equal to 0, so that's why. Okay? And the other reason is because you're trying to find where it's crossing like the x-axis, and what is your value of y when you're on the x-axis? 0, so that's part of it too. Okay? So what are my mini equations, Emma? No, once we get to other factoring, it will not. So the first one is x equals, not 7, 0. And the other one is x equals 7. So our answers here are 0, 7. So remember, there's two different ways you can write it up. These are the two different ways you can write it up. So you can either do it just by saying the x equals, or you can do it in the set notation. Do you guys all see that? I do not care which way you do it. All right, look at those ones, and then I'm going to kind of answer Justin's question from here, because he said, will it always be 0? And the answer is no. All right, so let's look at some factoring that is not going to lead to that. So the first thing you look for is if it is equal to 0. Is number 1 here equal to 0?
Yeah.
Okay, so we factor it. We look for a... Is there a GCF? No, but notice this one is a trinomial. Binomials, we look for difference of squares. What do we do with a trinomial? 3 terms.
Guess and check.
Our favorite guess and check.
Yeah.
So, x, what makes x squared? X times. Any way to make 6 is 1 times
6.
and 2 times. So if you weren't very good at this before, you need to know how to do it, right?
Yeah, man.
So we got to think about this. Our signs are going to be what?
Different.
One of each. So if I do -1 and -2 here. So that's -x, +6. Will negative x and positive 6 get us to positive 5x?
Yeah, man.
Yes. So we are going to have x minus 1, x plus 6 equals 0. And let's just make sure. Let's just distribute those middle terms. So that's 6x minus 1x. Is that what we want?
Yeah, man.
So we're good there. So I'm going to take that away just to make sure. Okay. Have we factored it? Have we factored it? Is there any difference of squares up there? There are no difference of squares. So are we done with the factoring?
Yeah.
So now we can create our mini equations. What are our mini equations, Connor Clover, in this one? Each multiplication is a mini equation. Not x equals. What's in that first parenthesis? X equals 0 because it's a zero product property, and there you go. So you guys notice it's the pieces that are being multiplied create the mini equations, right? So we have x equals and x equals. So our answers are negative 6 and 1. Okay. The next one there. Is it set equal to 0? Yes. So Cassie, we look for a GCF first. Is there a GCF? Yes. What is it? So I have 5x times 2x minus 3 equals 0. So now we have a binomial inside. Is 2x minus 3 a difference of squares? It is?
No.
It's a difference, but these aren't perfect squares, aren't they?
No.
So we can't keep going. So we then can create our mini equations. So Jack, what are my mini equations? So we have x equals and x equals, not 2/3, 3/2.
Yeah.
Hey, I mean, we'll take it.
You know.
It's better than the original 2/3, so. All right, look at that. And I'm going to stop. I'm not done yet, but what questions do you guys have so far? What's going on in that head of yours that you guys need me to go over? You know, the biggest thing, honestly, is that this is a main feature of the EOC. Also, this is like a main, like first semester of Algebra 2 is this stuff.
So aren't you doing this by junior year?
Well, you'll re-go through it, but you'll do it again. All right, so what needs to be done first? Josh, what needs to be done first in number 3? Colin.
You need to add 6x to the other side to make it equal to 0.
And make sure you put it in standard form when you do that. So the 6x needs to go between. Do you guys see that? So remember, we're using the 0 product property, which means it needs to be set equal to 0. We want to find when it's crossing the x-axis, which means y is 0. That's where that 0 is coming from. So is there a GCF in this problem? No, and it's a trinomial, so we have to use guess and check. What are our signs going to be in this one? Yeah, it could be positive, positive, or negative, negative, but this tells us it's going to be positive, positive. So 1x times 8x. Is that going to get us to 6x? No. How about 2x and 4x? So we have x plus 2 and x plus 4 equals 0. Are either of those difference of squares? No. So Grace, what are my mini equations?
X plus 4 equals 0 and x plus 3 equals 0.
Good. We have one here and one here. And it doesn't matter the order you do it in. So what Grace said was just completely fine. I'm just writing it because that's where mine is underneath it. So I get x equals... So this next one here, is it already set equal to 0?
Yes.
Is it already factored?
Yeah.
Yeah, we already have our mini equations, but how many pieces do you see this time? We are going to have 3 mini equations. Each separation, it would be possible if it is a cubic, which you guys really won't talk about until, again, algebra 2. But you do, any separation of multiplication needs to be set equal to 0. So we have 2 equals 0, x minus 3 equals 0, and x plus 4 equals 0. Something does not make sense up here.
2 does not equal.
So that's not true. So we're going to cross that off. So that means x equals 3 and x equals negative 4. So Riley, why are you confused? You literally just said none of it makes sense. So where are you confused at? Huh? Are you sure? I don't mind helping you. I just need to know because I'm sure you're not the only one. Are we doing okay? We have one more slide for today, and then we'll finish the notes tomorrow. So what needs to be done first on number 1 on this slide, Jana? We want to add 32x squared on both sides so it's equal to 0. Okay, Mike, what do I do now? Not yet. What do you look for first? What's the first step always? GCF. What is our GCF? Hey, he had the right letters. It doesn't matter. What do we divide both sides by?
8.
And? What variable? Don't forget your variable.
Oh, x.
So we can divide both by 8x. So we are left with 4x plus 1 equals 0. Is 4x plus 1 a difference of squares? What are my mini equations, Justin Powers? Equals and? So we have x equals 0 and x equals negative 1/4. Nope. So, we're going to skip number 2 and just do 3 and 4. So, is this one set equal to 0?
Yeah.
So, we list out the factors of the front, and we list out the factors of the back. What do we know about the signs on the back here? Will have to be one of, because it's a negative. Okay, so will negative 2x and positive 15x get us to 7x?
No.
How about 30x and negative x? That's even worse. Negative 6x and 5x. Negative 6x and 5x. Okay, how about 10x and negative 3x?
Yeah.
Okay, so we need to do it so that it distributes this way. So we need to do it so it distributes this way, so it's negative 3x and 10x, right? So we do our 2x and x. 2x needs to multiply with the 5, which is positive. And x needs to multiply with a negative 3. So if we distribute this, this is 10x minus 3x, which is our 7x. So we get 0 here. There was no GCF to start, so we're good here. Justin Crater, what are my mini equations? So x is 3/2, and x is negative 5. Okay, last one. Is it set equal to 0?
Yeah.
Is there a GCF?
No.
No, it's two terms, so is this a difference of squares? Yes, x times x and
X
5 times 5. So it is x and 5 and x and 5. Yep, one will have to be negative. I haven't done anything with signs, but you are right. So one of them has to be negative and one will have to be, which is our difference of squares, because that gives us negative 5x and positive 5x get a 0 in the middle. So we're using our zero product property now. And we get x equals 5 and x equals negative 5. Because it's funny.